morning, professors, teachers, and fellow students. We are from Emmanuel Lutheran College, and our registration number is 61424. The topic of our project is invigilators allocation by linear programming. First, I would like to talk about what are our motivations to do this project. At the very beginning, we have discussed with our teachers for a suitable topic of our project. After some time, we have discovered that invigilators allocation is a quite difficult and complex job, and also is done by manual work recently. So we would like to try to build a mathematical model to formulate the problem. There are three main objectives of our model. First, the difference between the total invigilation time of any two teachers should be as small as possible. Second, the teachers should invigilate their familiar assessment sessions, and also the efficiency of the algorithm is also a concern. We will set some constraints to meet the objectives. First, an invigilator should only invigilate at most one session at one time. Next, some sessions should be invigilated by the particular teachers. That means we have done this by pre-assignment. Next, some class levels are assessed while some are having lessons, and the lesson timetable should be included. Also, enough time are required before and after each session or lesson for preparation. The teacher is available if he is also available for the preparation time. Here I already talk about our methodology. We have searched for many journal papers before, but none of them is related to invigilator allocation. So there are mainly two approaches, but they are just for solving timetable scheduling problem, but we can use this to solve invigilators allocation problem. The first one is called operations research. The advantage is it can give an optimization of solution, but it's very time consuming. The other one is called artificial intelligence. It's very fast in finding solution, but it has two main disadvantages. First, some conflicts may be arising, and second, the solution may not be optimal. Here we have considered the approach of operations research first. Linear programming model is used. Several equations are used to build the model. Here is the objective function. The teacher who teaches the subject of the session will have a larger chance to be assigned as a invigilator. And the second one, this equation can assure the difference between the total invigilation times of any two teachers is within the predefined tolerance. Oh, I'm sorry, I'm talking about the point before. As this equation assures the difference between the total invigilation time of any two teachers is within the predefined tolerance, for example, 15 minutes. And lastly, the last equation can preclude each teacher from invigilating the different sessions at the same time. Here we have a demonstration to be demonstrated about this method. The program is running. While the program finished, the name of the teachers will be well filled in the boxes, and the time between each teacher of the invigilation time is just between a tolerance. For example, 15 minutes. Oh, it's complete. Let's see. Now the teacher is heuristically assigned. And the time between each teacher, you can see they're almost the same, or they just have a difference between 15 minutes. Okay, let me go back to the PowerPoint. The solution is optimal. It meets all our objectives and constraints, but it's very time-consuming for large data set. So for 60 teachers and 50 sessions, 3,000 variables are already used. So since the large number of variables, we should find another approach to solve this problem. There are mainly two ways in reducing the number of variables. The first one is to decrease the number of staff, and the other one is to decrease the number of sessions. Staff or sessions should be assigned heuristically first. And the session with long duration should be assigned first. The balancing is also important in the assignment. First, sessions which require only 1 or 2 invigilators. Next, the sessions with long duration. Last, the balancing is also important in assignment. So let's go to next. We are solving our level mode. How to solve it? We should formulate as a minimization problem, and we solve by over-filter algorithm. 3 parameters for each arc. There are lower bound of flow, upper bound of flow, and cost of flow. The result is p-assigned, and the mode is used until the remaining problem is suitable for our integer programming model. Here's the sample set of our level flow model. Let's see, we have divided into 3 parts. The first part is upper bound, the number of invigilators required. Lower bound is set as 0, and the cost is set as negative of the duration of session. In the middle part, the upper bound is set as 1, the lower bound is set as 0, and the cost is set at negative of the number of lessons that the teacher teaches the subject of the session. And lastly, the part we have set the upper bound is 1 and the lower bound 2 is 1. The cost will set as the negative remaining required invigilation time. Here's his example trend for how to work of the level flow model. This flow means that the second teacher is assigned to invigilate the first session. You see here T2, this means the second teacher. S1 means the first session. Yeah, to conclude our presentation, I would like to talk about the contributions. First, it is a classical problem, but no one have done it mathematically before. And we have used operations research techniques for solving invigilator allocation problem. And we have reduced the workload of teachers in doing administrative works. And our project is applicable, and our product is suitable for all kinds of schools. But of course, there's some weakness in our project. The solution may not be optimal if heuristic part is not applied. That's the end of presentation. Thank you.